Okay, this is the next lesson in Geometry, Unit 4, Congruence. Today we're doing a lesson called Congruence in Right Triangles. Okay, so everything for today is focused purely on right triangles. Right? So previously we have learned 4 shortcuts to prove triangle congruence: side, 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 angle, angle, and angle, angle, side. Okay. There is a 5th shortcut that applies to right triangles only, okay? Only for right triangles, okay? So just some terminology first. In a right triangle, the side opposite the right angle is the longest side, and it is called the hypotenuse. So in our diagram below, this is the right angle right there, okay? The side opposite the right angle is the longest side, and it's called the hypotenuse, which is this side right here. The other 2 sides are called legs, okay? So that's a leg, and that's a leg. All right, now let's get to our 5th shortcut. It's called hypotenuse leg, or HL for short, okay? So here's the theorem. Again, this is only for right triangles, okay? If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the 2 triangles are congruent, okay? The reason why this works is if you think about the Pythagorean Theorem, okay, the Pythagorean Theorem for right triangles says that a leg squared plus another leg squared equals the hypotenuse squared. So if this leg equals that leg, and this hypotenuse equals that hypotenuse, then when you apply the Pythagorean Theorem and you solve for the missing side, this missing side AB has to be the same as this missing side DE. So really, it's basically like you're doing side, 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 okay? So bottom line, if you have right triangles and you know that one leg is congruent to another leg and the hypotenuse is congruent to the other hypotenuse, then the 2 triangles are congruent by HL. So this summarizes what I just talked about. To use the HL theorem, you must show that 3 conditions are met. So again, this is just recapping what I just said. First of all, there must be 2 right triangles. The triangles must have congruent hypotenuses, and there has to be 1 pair of congruent legs. Okay. What additional information do you need to prove the triangles are congruent by HL? Okay, so example 1A. You may think you don't need anything for HL because if you look at it, I mean, you have that leg congruent to that leg, and you have that hypotenuse congruent to that hypotenuse. So you may think you don't need anything, but that's not true. You don't know that you have right angles or right triangles. So, I mean, I'm going to put a star. You don't know that this is a right angle, and you don't know that this is a right angle. Okay, you'd have to know that they're right angles. I'm going to say you need to know. So you need angle T and angle Q to both be right angles. That's what you need. You need to know that you have right angles. If these are right angles, then you do have enough. Then you do have enough for HL, because you already have that leg congruent to that leg, and you have that hypotenuse congruent to that hypotenuse. But you need to know you have right angles, and therefore right triangles. Okay, example 1B, we already have the right angles labeled. Nice. And we know that the hypotenuses are congruent because this is the hypotenuse that's congruent to itself. But you need to know that you have a pair of legs congruent. We don't need that. So I'm going to say you need either XV congruent to TV, or I'm going to say, or you need to know that RX is congruent to RT. Okay? You already know you have the right angles and therefore the right triangles. You already know that the hypotenuses are congruent because this hypotenuse is shared, reflexive property. So you need to know that a pair of legs is congruent. So you need to know either segment XV is congruent to segment TV or segment RX is congruent to segment RT. All right, let's get to the proofs. We got 3 proofs. Example 2. Given WJ is congruent to XZ, that's already labeled, good, and angle W and angle K are both right angles, prove that triangle JWZ is congruent to triangle ZKJ. The first statement is my givens. Reason 1 is given. If it's not labeled, label the diagram. Okay. Now this next step is very easy to forget, but it is required for hypotenuse leg proofs. You have to actually state that you have right triangles. Okay. Give me 1 second. Okay. Okay, so like I said, you have to actually state that you have right triangles in these proofs. That is required. So this next step, you must say, okay? I'm going to say triangle JWZ and triangle ZKJ are right triangles. You have to actually say that. That is called, there's no property or theorem for that. That's just called, I was going to say definition of right triangle. Since you know you have right angles, then you can say you have right triangles. Definition of right triangle. You have to say that step. You cannot skip that step. That is required for these proofs. Okay? But now I'm going to use the reflexive property and say that JZ is congruent to JZ. And now I have hypotenuse leg. Look, hypotenuse leg, and you already said we have the right triangles. So I'm going to say that triangle, JWZ, is congruent to triangle ZKJ by hypotenuse leg. Okay. Example 3, given that MJ is perpendicular, that means perpendicular, to NK. Ooh, NK, huh? And then MN is congruent to MK. Prove that triangle MJN is congruent to triangle MJK. Okay, so here we go. First statement is my 2 givens. Reason 1 is given. Now here's an interesting thing, okay? I have to, eventually, like I said before, we have to state that we have right triangles. But first, we need to say that we have right angles, okay? So what I'm going to do is, since MJ is perpendicular to NK, it means that that's a right angle, which is already labeled, but it also means this is a right angle. So that could technically be labeled too, but since MJ is perpendicular to NK, it means that this is the right angle and this is the right angle. So for my next step, I'm going to say the following. I'm going to say that angle MJN, J has to be in the middle for this, and angle MJK are right angles. I'm going to abbreviate angles with the angle symbol, okay? And that is the definition of perpendicular. because they're perpendicular, that means we have right angles. And now, since I have right angles, think back to the last example, now I can actually state that I have right triangles. So I'm going to say triangle MJN and triangle MJK are right triangles. I'm going to put the triangle symbol. Definition of right triangle. We did that in example 2. Now we're going to use the reflexive property on this leg that they have in common. I'm going to say MJ is congruent to MJ. Reflexive property of congruence. And now let's say, now we can say what we have to prove because we have the right angles and therefore the right triangles. We have hypotenuse, leg, hypotenuse, leg. So triangle MJN is congruent to triangle MJK. By hypotenuse leg, HL. All right, one more. CD is congruent to EA. Let's label that because it's not labeled. AD is the perpendicular bisector of CE. Those are my givens. Okay, so there's a couple ways I could start for step 2. Since it's the perpendicular bisector of CE, it means CE is cut in half, so I'm going to take care of that part now. I'll say that CB is congruent to EB. I'll do that part next. I'll say definition of perpendicular bisector. Okay. What else do we got? Well, since it's perpendicular, since AD is perpendicular to CE, it means we got right angles being formed. So I'm going to label that as a right angle, and I'll label that as a right angle. Because they're perpendicular, so they form right angles. So for my next step, I'm going to say angle CBD and angle EBA are right angles. Angle CBD and angle EBA are right angles. Again, I'm going to say definition of perpendicular. And now I can say that triangle CBD and triangle EBA are right triangles because I have the right angles. Definition of right triangle. This looks better like that. And anyway, now we have the right angles and the right triangles, therefore. We have the hypotenuse is congruent, and we have a pair of legs congruent. So I'm going to say triangle CBD is congruent to triangle EBA by hypotenuse leg. Again, this only works in right triangles. So that is the end of that lesson. That lesson was not too long. That was called Congruence in Right Triangles.